So like I'm saying, lecture is on water pollution issues, but we are going to look at it from two angles. We are going to look at it from the angle where this water that we use in these factories, these industries, the mine environment can affect the human heat balance. And the second thing is how this water that is used in these various industries can affect the ecosystem. These are the two angles we are going to look at. And I've also been told you've started with your lab session, which talks about the water parameters. So for this lecture, I will not mention water parameters. It is just these two angles that we are going to look at. So for the main chapter, the content is water used in industry. The water that is used in this industry, how does it affect the human heat balance? Then we will go on to look at the aquatic ecosystem. That is how these water bodies affect this aquatic ecosystem. Then we will look at the water pollutants. Look at the water pollutants. The end is water quality parameters, which we have done already. Water quality parameters, which we have done already. Now, in the industries, like I said, large volumes of water is used. Very large volumes of water is used. So water is utilized in many stages of mining and mineral processing and other industrial processes, not limited to mining. What is this water used for in these industries? There are three main things that this water is used for. One, for cooling equipment and machine parts. You know, they generate heat. And then to maintain this equipment, you have to cool it. And then again, to take out the heat from the work environment, you would have to cool it in water. And mind you, whilst you are cooling this equipment, machine parts in water, the water gets hot. So that is one use for water in these industries. The second thing is processed water. For production, we use water. Sometimes, because you have to excavate, you have large amounts of soils that or that contains the mineral of interest. Transporting it becomes difficult. So what is usually done is you mix it with water into a slurry. So another use is processed water for processing. You look at the details in time. I just want to let you know the three things that water is used for in the industry. Then for transportation, moving the material from one place to another. For cooling, for processing, and for transportation. Now we will look at this use in details and find out how these processes can affect the human heat system. Now let's look at, for a long time we have talked about human heat balance, but for the water it is now transitioning to technical management. The water used in this industry is just purely for technical management, the management of the processes. Now we are using it to cool. It is part of the management of the industry. And what is it specifically saying? To cool, the first one, to cool equipment. Example, crusher bearings. You know, when you are crushing, the balls become hot. And if it becomes hot, it releases heat into the work environment. Like from the last lecture, we said if the environment within which you work, is hotter than your core temperature. Your core temperature, which is around 37 degrees Celsius, and it is lower, the environment, the heat in that environment will push heat into the human body. And in that case, though the human body, the temperature is high, the human will not be able to sweat. Even if it sweats, it will not be able to evaporate those heat. That is one thing. So what it means is that we can absorb massive amounts of heat without its temperature rising too quickly. That is what the industrial heat system does. It will help people. Mute yourself. So the cooling would help reduce this heat that is coming from these operations, from pumps. Even pumps, it comes with slurry, the materials, the frictions between the grains or the particles generate some amount of heat. Then we have compressors. We have electricity generating plants. All of them generate some amount of heat. And some of the equipment, they have to cool at a certain temperature. And so there's a need for us to cool this equipment. Now, how does cooling this equipment result in affecting the human heat balance? This is what happens. So if the heat is cooled in the water, there would be evaporation. The water body or the cooling system will start evaporating. The water in that cooling system will start evaporating into the wet environment. So now you don't have dry environment or dry heat. Now you have wet heat in that environment. Wet heat means that the humidity would increase. When humidity increases, you are not able to sweat the way you are supposed to sweat. What does sweating mean? Sweating means that your core temperature has increased and you have to release some amount of heat. And so if the place is very humid, you cannot evaporate the sweat. It means the core temperature will not reduce. And if it doesn't reduce, it would now drift into some heat illnesses. So this is how this cooling can affect the heat balance. And so how do we do it? What do we do? To ensure that, yes, we are cooling to take out the heat from the equipment that we are using. But in another breath, it is being released into the work environment. What do we do? From the previous lecture, the video I sent, it tells you that you have to know the baseline of that place. And then if there's a need for you to pump cold air into that environment, cold air will not solve the problem because of air compression. The compression of air that results in heat, just pumping cold air into that environment is not enough. You have to pump in refrigerated air. That is what you have to do. Now, let's look at the next process, the use for water in the industry. Now, we said processed water. It is used in wet screening, gravity separation, that is shaking table, gates, flotation, washing water, fines from metal oils, clays from stone, wet scrubbers for air pollution. This is the processed water. So if we talk about process, what is it used for? We have mentioned, so these are the uses. And wet scrubbers for air pollution control. That is what the wet scrubbers for air pollution control. You will look at this. This is pollution control. At the end of the day, we expect that clean gas will go out. So this scrubbers is supposed to filter whichever thing is in the air. But at the same time, we are using water to do that. So from shifting from cooling water, we go to processed water. And what does the processed water do? And that is what we have listed. We have listed that we are using this processed water to clean the air. So if the water is used for washing in hot environment, and this environment is the gases, what do? And again, we would also want to reuse this water. That is the reason why you cannot just discard the water. First, you want to clean the air. Second, you want to reuse this water. So you have to recycle it. But some companies, they do not recycle. And so they will release this hot water into the environment, and it has an effect on this environment. What will you do? It would increase the temperature of that work environment, because this machine, though they are out, there are buildings around it. This scrubber is out, but then trying to clean these gases, it would increase the amount of heat or the temperature of the environment. So what do? Or how does it increase the human heat balance? What it does is that it will increase the temperature of the work environment. Like from the last lecture, if it increases the temperature and your core temperature is higher than the environment, it means you will lose more heat into the environment and you start feeling cold, or the vice versa. You will not take in more heat, that will break your system, increase the heat illnesses in your system. Now, why does this matter for human heat balance? So when humidity is high, because I said it would evaporate. First, it will clean the gas. So we have clean gas getting into the environment. Second, the water is hot. If the water is hot, the temperature around or in that environment would increase. And when it increases and there is moisture in the environment, the humidity will go high. The humidity will go high. The humidity will go high. And so if humidity goes high, you will not be able to breathe well, or you will not be able to release enough heat into the environment. So that is how it will end up affecting the human heat balance, though the main problem is to clean the air. Now, the question is, what do you do in this regard? When the humidity gets high because of the temperatures from the water use, what do? That is when ventilation, flushing of the air becomes very important. Mind you, this is surface environment. What if you are doing this in the subsurface environment? Subsurface means underground. deep down below or getting to the earth crust, what do you do? Temperatures are increasing. What do? You would have to put in the system. So water, yes, is good to cool the system. It is good to filter the gases. But one thing you cannot forget is the fact that if you do not control it, it will affect the people working in that environment. So this is shaking material. These are ways of using water in the industry. We use large amounts of water. It might not be hot water, it is cold, but how do you discharge it after washing your materials? What do you do? Do you release it directly into the environment? And if you release directly into the environment, what happens? It will affect the environment. Another thing is that this is the example of shaking table. The metallurgists use it. This is just to separate the mineral of interest from the waste. You shake it, the mineral of interest will be collected at a point, and then all those that are not needed would be washed away. So these are examples of how water is used in the industries and work environments. Now, another way of using water is transportation. Like I said, you have your ore that contains the mineral of interest, or you are in a factory that needs to transport some materials. But if it is in the dry form, it becomes a problem. And so it has to be in a slurry form. What will you use to transport it? It is water. And sometimes the water, if the temperature is high, that is when it can affect the human health balance. Mind you, all this process sometimes are in an enclosed place. And if it is an enclosed place and the materials used for closure has high conductivity, then you know that the transmitting of this heat will be slow. But if it has low conductivity, then the transmission will be high. And again, it is the people who work in the environment. They will still be there working. If you go to aluminum companies, rods for building, it is high amounts of heat. And so when they bring it out of the fire, it has to be cooled because you cannot handle it when it's that hot. It has to be cooled. And when it has to be cooled, people work in that environment. What do you do? These are things that you should put in mind and know that no matter your role in that work environment, the heat can affect you. So if heat can affect you, then you can now encourage the right thing to be done. If you are the one in charge of that environment or you are the supervisor in that environment, then the measures must be put in place. So it is not enough to say that water that are used for cooling does not have any effects on anybody. It can and will, if the right systems are not put in place, affect the human heat balance. I don't know if you listened to the lecture I made yesterday. Of course, you've all done the assignment. That means that you understand the human heat system a lot. Some people did not get it, but the video I have sent is supposed to explain these things to you. Now, in a deep mine, or let's say a closed factory, the transportation is very important to take note, especially if the water is hot. If the water is hot, there's a need for you to pay particular attention. So water is not only used for the cooling or washing or the processing, it's used for the transportation. When you move thousands of tons of materials, you don't expect the water, even if it is not hot water you are pushing, but the force, the frictions in the sample would increase the heat in that environment. And then you have conveyor belts working, you have machines moving. From the last lecture, I mentioned that natural sources of heat, the artificial sources of heat, and transporting these materials in a slurry form, we do it with machines. So apart from the water plus the material reacting or frictions between them generating heat, the equipment that aids the movement also increase the amount of heat in that environment. So how does moving this man through a pipe make the workplace hot? This is what it is. How does it do it? And I have mentioned it, when we are pumping this slurry, it requires massive amounts of energy from the equipment. Is it from electricity? Is it from generators? The conveyor belts going, it generates some amounts of heat. And then so if it generates amounts of heat, what happens? The worker is standing near the pipe. You know, that is the thing. You are supposed to put in on PPEs. There are guidelines, but people still work in that environment. No, the machine would work, but we need a human to regulate things. So the human will be very close to the pipes. And these pipes gain heat. When they gain heat, the heat will not be trapped into the pipes or the tubes that are transporting this slurry. They will definitely release some amount of heat into the environment. Now, if there is heat released into the environment and then the humidity goes up, now we don't have dry heat there. Now we have humid heat. And from all our lectures, we've mentioned that when the humidity is high, we cannot breathe well, release heat or sweat well. We might sweat, but there wouldn't be evaporation, because high humidity means that we almost get into the saturation point. So these are the ways that we get the human heat balance affected from the use of water in this industry. The thing is, the water being used, the intention is to cool the equipment and to remove heat from the work environment. However, it also finds its way, the heat from the cooling finds its way into the work environment. That can affect the individual in that work environment. Other water uses in the industry: dust control, vehicle washing, domestic, and sanitary. So from even the other water use, it tells you that the intention for using water in this industry is to solve a technical problem, is to solve some problem. Machines that are too hot needs to cool down, but the intention is not to increase the temperature in the work environment. But then that is the side effect. There would always be temperature being increased. Of course, there are situations that the temperature might not increase to the extent of getting into the work environment. It would be in the water, it doesn't get into the work environment. However, if it gets into the work environment, that is when we have to put in measures to ensure that the work environment is conducive for the people to survive in. we know when the temperatures increase, we know how they can affect us. And that is dangerous. So we should not always think that gases, particularly those that we can smell, we can see, are the only thing that can affect the human, the equipment in that work environment. Heat is also another dangerous thing that can kill or can be fatal. So we have to put in measures to try to curb the amount of heat in the work environment. From the lecture, we have seen the negative effects of heat. Apart from the fact that it can be fatal, it can affect or destroy equipment. Some temperatures get so high. If you go to the environmental monitoring lab, the same equipment, for instance, it is under air conditioning 24/7. Because as soon as the temperatures increase, the equipment will break down, and that equipment is very expensive. So in your work environment, you are electrical engineer, mechanical, renewable engineer, you are working, and the equipment you are working with cannot stand certain temperatures. So you can't say because it would affect the human in that work environment, you will not provide the right temperature for your equipment. You have to provide the right temperature for the equipment, and in doing that, you still put mechanism in place so that the people who work in that work environment would survive and be very comfortable. And if they are not comfortable, sometimes it does not get fatal, but it is so uncomfortable that it affects production or performance. And at the end of the day, every factory needs or wants profit. And so if the conditions are not right and people are not performing to their maximum, then it affects the company at the end of the day. The influence of other activities of mining and construction. So it is, this time it's not like deliberate using water, but the activities of mining or other activities can influence how water is behaving on those industries or in those companies. So if you are pumping water from, let's say, a deep underground, underground, you are pumping water. Yeah. Because once you are drilling down, going down the crust to work, there are places that you would find water, and the water would hinder your activities. And so if they are hindering your activities, it means that you have to pump those water out. So the influence of other activities of mining and construction is the pumped water from water influx due to rainfall or underground interception. You are going down, excavating, drilling, it gets to a point you get water. It can influence the activities of mining. So if you pumping water from this deep underground, that water is naturally hot. Why is it hot? Because we have mentioned that when you are moving down under sub environment or deep down the crust, the temperature increases. But subsurface, that going up from the surface, the temperature decreases. And so this water will be hot. But again, because the water is hindering your activities, maybe if it's mining, if it is construction, you are trying to construct a very deep underground tunnels or whatever it is, and you meet water, you have to pump it out. And then pumping this out, what does it mean? We are coming out with hot water. So as the hot water will travel through the pipes, in that work environment, it is hot. it gets hotter. So what do? You will still have to pump it out. And it is in that wet environment. What does it mean? The heat from the water will move into that wet environment. And that can affect the human heat balance. That can either reduce the core temperature or increase the core temperature. But in this case, if the water is hot and then heat from water gets into the environment or the work environment, it will pump this heat into the human because the human's temperature is lower and the temperature in the environment is hotter. You have to find a way of cooling that. Another activity that can hinder or influence activities of mining and construction, for example, is runoff after rainwater or snow. So this runoff usually occurs when water flows freely over the ground. So runoff, you know, when it rains, you see water moving on the ground surface. But in this case, if the runoff is in a factory, that the temperature, the water has high temperature, we know that there will be evaporation from those water. And when there is evaporation, it gets into the work environment and increase the temperature of that work environment. So in this way, it can affect the human or the personnel working in that environment. Another way is percolation of water into stumps. When we talk about percolation is when water seeps through porous materials. You know, some of the rocks themselves, they are porous already. There are cracks in them, there are features in them, and there are water. If you listen to the lecture that I sent, I mentioned that another natural source of heat is heat coming from feature waters. When we're looking at feature gas, we said some gases are trapped in water that are in cracks in those rocks. But in this case, this water that are filled in these cracks get hot. And when they get hot, they are released into that work environment, increasing the temperature of that place. So heat from the water or heat from the rock gets into the water, and then from the water, it gets into the work environment. And so if you are drilling, excavating, whatever you are doing to get into the crust, the earth crust, and you leave cracks in those rocks, water fills them, heat from the rock, the virgin rock that you have disturbed, now moves from the rock, gets into the water, and then from the water, it gets into the work environment. That is another way that influences mining activities that at the end of the day gets heat into the work environment. And another thing is leaching of ore. So that we have rocks, if the rocks are not disturbed, from what we have said, even with gases, that it is stacked or it's adhered to the rocks. If you do not disturb it, the gas does not move into the work environment. These same rocks, if you do not disturb it with certain conditions available, they are safe. There are certain rocks that have sulfides in them. They don't have any problem until there is presence of oxygen and water. Like we are saying, when you are drilling down, you meet water. And if this water comes into contact with rocks that have sulfides and there is presence of oxygen, then they would leach or they turn into acid mine drainage. And this acid mine drainage, you know the acid, and so they get into certain environments. Heavy metals are able to dissolve into these waters. And if heavy metals are dissolved into this water, and this water find themselves into water bodies, they would affect these water bodies. The living things in there can be affected because their pH will change. And if the pH change and the organisms cannot survive in those pH, they will die. These are some of the activities that influences mining and construction. And these activities sometimes would affect the heat and sometimes will affect the environment, or let's say the ecosystem in general. Another one is groundwater interception during excavation. Spillage of substances to contaminate surface and underground water. Then aerial pollution usually fall out to affect surface water. These are all ways of mining or construction or any industrial activity can affect the environment. This is what, so you are drilling down, you are excavating, you are doing everything to get into the crust and do your mining. You can intercept groundwater. And if you intercept the groundwater, what happens? We have mentioned it. This water is usually hot because we are digging deep. And what we have mentioned is that once you dig deep into the crust, the temperatures increase. And so if the temperature is increasing and you get groundwater, the groundwater will get hot. We have spillage. And this spillage refers to the accidental leak of industrial fluids. Maybe, look, you have chemicals that are supposed to be used for processing, for leaching, or for taking out the mineral of interest. And accidentally, it's an accident, it spills. When it spills, what's happening? Usually this slurry or these chemicals are hot. Two things. They can release heat into the environment. That is another way of releasing heat into the work environment. Or they would affect water bodies if there's runoff. So in all this, yes, we are using water in large volumes in the mines, in our industries. There are two things that can happen when we use this water. First, it will definitely do the work we want it to do, like cooling, processing, and then transportation. The water will do them. But the other effects from using this water in cooling, for instance, is that it will release heat into the environment. And sometimes when we do not control it and there's accidental spillage, this hot water will get into the environment. It can get into hot water bodies. It can get into places that are not supposed to be, they are not supposed to get to. It can get into farmlands. It can contaminate a whole lot of things. And so whilst you are using these large volumes of water in the mine environment, you have to put precautions in place to protect the equipment, to protect the people living in that place, and to protect the environment in general. It's water, plants, protect it. Because from all this lecture, we have understood that all these four spheres, they do not live in isolation. Yes, you are using water, but at the end of the day, it's that environment or the atmosphere of that environment that is also affected. It can affect the land, it can affect the humans. And so whilst you are doing it, you have to check. And in doing all this, you have to keep in mind the threshold limit values. You have to keep them in mind. Measure the temperature, the threshold, the allowable threshold of temperature in that work environment. Even if you are cooling the temperature, you have to keep the threshold limit value in mind. With that, you are able to put things in order and for the human to survive in that work environment. Now, we have talked about how the water we used, which is supposed to be helping us solve certain problems, can affect the human heat balance, because we know those heats can move into the work environment. Another thing is, yes, we have the water solving our problem, doing what we want it to do. But again, it can affect aquatic ecosystem. When we talk about aquatic ecosystem, we are just talking about the water ecosystem. Aquatic is water, so where water bodies are found. There are some companies, I have said that when it comes to the environment is able to withstand certain pollutants that are released, some level of pollutants that are released into the environment. So again, if you have a factory and you have to release hot water into the water body, you have to ensure that the hot water you will release into the water bodies does not change the condition of the water bodies. How does the changes occur? It does not change the physical, chemical parameters and biological parameters of the water bodies. And you have seen water parameters already. You went to the lab, or the lab people explained to you the various water quality parameters. These water quality parameters you have to meet. And so before you release this water from your industry, it is not only hot water, it can be waste water. Waste water from your industry, you are releasing them into the aquatic ecosystem. You have to test the water to meet certain criteria before you can release them into the environment. So aquatic ecosystem, a breakdown of ecosystem life cleaning capacity may be a result of any or both of the following. If there's a breakdown of the ecosystem self-cleaning, just like I have said, the water body, if you release certain amounts of pollutants, it will be able to clean it by itself. It has its own mechanism. For instance, you have released a lot of nutrients into the water bodies. There are other organisms that need those pollutants or nutrients to survive. However, if the nutrients overwhelm them, is too much, they cannot decompose everything, or they cannot break down everything as nutrients. And so when they are in that water body, the amount of oxygen in that water body will reduce. And at the end of the day, the water body will die. If you come to Ghana, for instance, those who have heard in the news or those who know in Accra, the Korle Lagoon. The Korle Lagoon, for instance, is a fresh lagoon, but because of the squatters, Sodom and Gomorrah, people living in those areas, they don't have sanitary conditions. They release wastewater into the lagoon. All sort of things go on in the lagoon. Now the lagoon is dead. If we say the lagoon is dead, it means that the amount of oxygen that is supposed to be in for organisms to survive is depleted. So that is the same way in the industry. If you release certain chemicals or pollutants into the water body, there will be a problem. Some years back, Newmont accidentally spilled some of their tailings into water body. It was a big issue. So if you look at the tailings dam, for instance, there are wells around the tailings dam, which is tested all the time, because if that well gets polluted, it means that the tailings is leaking and something needs to be done about it. So if the aquatic ecosystem, everything you are sending in, it cannot clean itself, then we say there's a breakdown. And under what condition would we say that there is a breakdown? It is when overloading a particular conversion. Example, introducing excess organic matter, like I said, nutrients. Too much, maybe NPK, all those nutrients are in your water that you are releasing. It's good for organisms to survive, but if it's too much, because if there's too much food, the organisms will be multiplying, growing very fast, but the amount of oxygen they need to survive in that water body will reduce. Then we come to survival of the fittest. Those are fit will take over, and those who are not, they'll die. Then eliminating one or more stages. When you come to aquatic ecosystem, it has its own cycle. We have nitrogen cycle, oxygen cycle. All these cycles are supposed to be working hand in hand. They are supposed to be in place. So for instance, in all this cycle, oxygen is off. Oxygen, the organisms in there need it. So if oxygen is not there, there's a break in that stage or step, then the ecosystem is termed as it has broken down from cleaning itself. This is some of the reason. And another thing is that in all this, the intention is to keep the aquatic water body at a level, or the cleanliness should be such that the organisms will be able to survive. That is when the parameters of the water comes to play. The parameters are very important to play. Now, a substance is a water pollutant depending on the following. Just like we've talked about air pollutant, we said it is not enough to say that because we have released gas into the atmosphere, we will say it's a pollutant. We said it's a pollutant when it met certain criteria and when it can affect the human. The same way, when we talk about water pollutants, there are parameters that it should meet. We can't say because we have introduced waste into the water, so it is a pollutant. No. First, the type of pollutant is important. You can't say you have introduced DDT into water and you don't call it pollutant. No. But even with that DDT, what is the concentration of it? Even if it is organic matter you are introducing to the water, what is the concentration? The total load of pollutant discharge, how much are you discharging into the water body? The nature of receiving water. What is the characteristics of the water that you are releasing your pollutant into, that you are releasing your hot water into? What is the temperature? What is the volume? Is it a small lagoon or is it a very large one? All of them you have to take into consideration. The nature of the receiving water, that's what we talked about. The capacity of receiving water to absorb the waste load. Will it be able to absorb? How much will you introduce into the water body? And you say that it is too much. You have to look at all that. So all these characteristics will come together for us to now determine if the water or the substance is a water pollutant. And mind you, it doesn't mean that you have to meet all these conditions before you can say it's a pollutant. It can only be concentration. The concentrations are very high. So you can just say that it is a pollutant. And mind you, the threshold limit values should also have a say in it. How much are you sending into that water? What is the volume? All of them would play a part in it. Now, another thing we also have to look at is specific water pollution problems. What are the water pollution problems that we can face? Deoxygenation, then acid mine drainage, eutrophication, heavy metals. Now, the water we use in the mine environment, sometimes we need to do something to the water so that our equipment will be protected. Sometimes we take out oxygen from the water before we can use it for our cooling. The reason being that when the oxygen is still in that water, it can corrode the equipment. So deoxygenation, we take out the oxygen from the water body. And another thing, we will go into detail, like the acid mine drainage. I mentioned it. Acid mine drainage, when there's sulfide mineral, and then there's oxygen and there's water in that in that environment, it can generate into acid mine drainage. And this acid mine drainage, when there's runoff, they move into water bodies. They can affect the pH of the water body. And now when we talk about eutrophication, eutrophication is the increase in nutrients in water bodies. The nutrient is so much. Somebody asks, okay, if the nutrient is high, then it's good. It's a lot of food for the organisms that live in that environment. Yes, it's a lot of food, but if the food is too much and the organism keep multiplying more than the amount of oxygen in that water body, then we will know that it can affect them. How does it affect them? Some of them will not get oxygen, so they will die. That's what we call fish kill. Then heavy metal pollution. If heavy metals from your processes are released into the environment, we know, even if you have arsenic in the environment, you know how much it can affect that environment. And they are poisonous. We have mentioned how some heavy metals in water bodies can affect that water body. It can affect drinking water, especially if it is released into water bodies that are used for domestic purposes. They can affect us. So these are some of the specific water pollution problems. Like I said, that deoxygenation, removal of molecular oxygen from a reaction mixture or solvent. I mentioned that if we remove this oxygen, what it does is that it prevents rusting. It will prevent rusting of the equipment, because the equipment you use in these industries are very expensive, and if they are expensive, they would definitely be protected. You will do everything to protect the equipment. And so you would want to take out the oxygen to prevent it from corroding, rusting. And of course, the purpose of the water is to cool the equipment. If they are cooling the equipment, that is what you want. You don't want to cool and destroy the equipment at the same time. So you would want to remove that. So that is some of the specific water pollution problem. And then guess what? When you remove this oxygen from it, you cool your equipment. Now you have to release into the water body. Now you release water that does not have oxygen in the water into the water body. And that same water that you are releasing has a lot of nutrients. Lots of nutrients the organism there would eat, they will multiply, but the amount of oxygen in that water is lowered. So in this case, what do? The best thing to do is to recycle this water that does not have oxygen for your cooling process. You do not release it. But again, in these big companies, there's recycling of water a lot, because the volumes of water they use, if they have to be discarding all the water and using fresh batch of water, the amount of water will definitely deplete. Wherever they're getting the water will get depleted. So there's always recycling of water. But in a situation where you cannot reuse that water and you definitely have to release it, then you have to find a way of pumping oxygen back into the water before you release it. So that is what I'm saying, that the water you have to release, you have to check the parameters, the water quality parameter, depending on the purpose of the water. The water, is it going back into the water bodies, or it is going to be used for agriculture, or it is going to be used for spraying of the road to prevent dust? You have to look at all that before you determine what to do or the remedy to put in place for that water you have finished using. Another specific water pollution problem is the acid mine drainage. With the acid mine drainage, or sometimes you call it acid rock drainage, like I said, when there is sulfide minerals that are exposed to water and oxygen, there's oxidation. If there's oxidation, we get that red kind of water. That is acid water. And acid water means when they get into certain rocks or certain environments, they dissolve heavy metals. And when they dissolve these heavy metals, they are released into water bodies. Water bodies that are used for domestic purposes, for drinking, for example, becomes hazardous for the people who use those water. And again, when you release this kind of acid mine drainage into water bodies, what happens? The pH can change. The pH of the water body that is receiving the acid mine drainage water, the pH will change, the conditions will change in that environment, and the organisms that live in that environment becomes affected. That is what it is. So we have to make sure we are putting things in place. Acid mine drainage in mine environments is not something that is not possible. It is because of the kind of rocks that are worked with. I was once traveling to Kumasi, I passed through Anyamfo in that area. I saw this acid mine drainage, red soil. So these are some of the things that can happen in your factory. And acid mine drainage is one thing that we really need to take particular note of because of its devastating effect it has on water body and the environment. So these are pictures of acid mine drainage. So if you see this red color around, there is acid mine drainage. Sometimes the presence of iron is also has this color. So sulfide mineral is available, there's oxygen, there's water, then there's oxidation that gives us this kind of water. And so in this water body, how do the organisms survive? Even if there are plants that grow in those areas and the condition or the parameters does not meet it well, you see them not growing very well. These are some of the effects of acid mine drainage. Now we talk about eutrophication, a process whereby water bodies such as lakes, estuaries, or slow-moving streams receive excess nutrients that stimulate excessive plant growth. We call it algal bloom. That is excessive plant growth. It is not only excessive plant growth, but when it's excessive plant growth, algal bloom. There are situations where you will see the fishes even growing. There was a report in the news where they said some fish pond, they woke up early in the morning, all the fishes were dead. They had died. As soon as I heard that, what came to mind is that there was too much nutrient in the water body. But you know, when people don't understand, as soon as there's so many narratives and all that, too much nutrient. And so when there's too much nutrient, they don't get the oxygen. There are so many of them. You can even be, maybe there's an area, you've always seen that there are plants there. Then all of a sudden you wake up one morning, the amount of growth is very high. It is because of this excess nutrient that has been introduced there. Then sources of nutrient into water bodies, fertilizer application, decomposition of nitrogen from the atmosphere, erosion of soil containing nutrients, sewage and wastewater treatment plant discharges. Yes, the factory, what do you discharge? All of them. So these are some of the effects of water pollution. Now, this is a picture of the algal bloom. You see this, and this affects so many other things apart from the nutrient side where there's algal bloom. There are leaves that cover the surface of the water, and the organisms in there, they need sunlight in there. They need the water air contact to get oxygen in there. So if you have algal bloom covering the surface of the water, you don't get the sunlight because there are organisms in there that need sunlight to produce their food, and those food, other organisms depend on them for their nutrients. And so this becomes a chain of problems for the aquatic ecosystem. So these are the leaves I'm talking about, covering the surface of the water bodies. When it happens like that, whatever it is, they will not get. And again, it becomes a nuisance for water travel. When there are boats and things on the water bodies and these plants are on it, they hinder the travel and they can even cause accidents. So it becomes a nuisance. At the same time, it becomes danger to the organisms that live in the water. Now, we said eutrophication can come also from sewage and wastewater. These are wastewater. When they finish, they have to discharge it. Just look at in Accra first, sewage from septic tanks were released straight into the sea, which is very wrong. But now there's a system where the solid part of the sewage is sieved before the water is treated to a certain level. Like I said, the water can be released, but before you release it, you have to look at the parameters so that they meet the criteria for which you are releasing it all into the water body. So you have to look at that. So this sewage will go into the water bodies. How will they go into the water body? Are you going to release them like that? You have to check the parameters. If it's going into water body for domestic use, you know what to do. There are certain water, they treat it very well. It will be good for domestic purposes because every kind of analysis has been done on it and it will meet the criteria. Sometimes they are just released into irrigation systems for watering crops and the likes. Now, heavy metals, there's so many heavy metals. If we have these heavy metals in the water that is being released, then there is a problem. We have arsenic, lead, cadmium, nickel, mercury, chromium, cobalt, zinc. All these heavy metals become a problem. You cannot release, and they are dangerous. And these are the sources: areas of intensive industrial activity, roadways and automobiles, brakes. The brakes can give copper, tire wear, zinc, engineer or motor oils. They have accumulated metal, different type of metals in it. And so if we have runoff on roads, we know the car tires are always moving. And this part of the world, a lot of us don't even use brand new tires, worn out tires that people don't need. That is what is being used all the time. And so you will realize that these heavy metals definitely will end up in runoffs that can lead to water bodies. And these water bodies, human will get in contact, plants will get in contact, and they would affect us. And these same tires are used in these industries as well. So these industries are the bigger industries that need to put precautions and know when to change those tires in their lives. So this is what I am talking about. So the runoffs carry them to water bodies after rainfall. That is the danger of these water pollution problems. So these are some of the heavy metals: the leaded gasoline, tire wear. If you look at the zinc, it's tire wear, motor oil, grease, iron, vehicle body rust, engine parts. They release all that. Chromium, air conditioning, coolants, nickel, diesel, fuel and gasolines, cadmium, tire wear, fuel burning, copper, bearing wear, and the likes. So all these things, that is why it is not advisable to just wash your car. Maybe you have a car washing bay that goes straight into water bodies. It has to be treated. There should be a collection point where this water is treated before releasing. But this part of the world, this regulation is supposed to be regulated, but we don't get it. You get, even go to the big companies, they are changing oil. How are they changing? Are they cleaning? If you go to Bogoso Junction, for instance, they change oil and it is on the floor. There is rain, there's runoff, it moves, finds its way into water body. When I came to this town some years back, there's a river called Bedianko that people were fishing in it, and even children have drowned in them. They were deep, they were around Kampunasi. Now you don't see that river again. People have filled it to build homes. But at the end of the day, how do we get flood water? Where would they go? That is the problem of this water pollution. So this is not the end of this chapter. We have more, which is the water pollutant. The toxicity to aquatic life. The end of using or understanding that water used in the mine or industries can have an effect on the human heat balance, as well as have an effect on the aquatic ecosystem. Now, if it has an effect on aquatic ecosystem, how do we measure it? The toxicity to aquatic life. We use the medium tolerance limit. That is how you will know. And this medium tolerance limits the range of concentration of a pollutant in which populations of test organisms, we use certain organisms to measure if the pollutant in the water is toxic to the aquatic life in there. So we use fish, for instance. If the fish suffers 50% mortality within a specific time, normally 96 hours, then we will say that the pollutant that is introduced into the water is toxic to aquatic life. That is it. So we use the fish, the trout or the goldfish to determine if the pollutant you are releasing into the water body is toxic to the aquatic life in there. And then it is not the only thing, but this is one way of determining if the pollutant you are releasing into the water is toxic to aquatic life or not. Aquatic life or not. Then there are other parameters that you can use to check it. So we use the TLM96 or we say 96 LC50. So within 96 hours, if 50% of the organisms you are using to determine if the pollutant is toxic to aquatic life or not die, then we will say that it is toxic. 50% of the organisms died. And then toxic, you know, there is death, but it can be nutrients. If the nutrients are too much, then it will cause 50% of the organisms to die. The temperature is too high, that it will cause 50% of the organisms to die. The pH has changed so much that 50% of the organisms will die. Then we are saying that that is a toxic pollutant. And we have other parameters that we use to check, the water quality parameters. So using the fish to determine if the pollutant you are introducing into your water body is toxic or not, we have water quality parameters that you have to look at. And all this you have already done, or it is being done in the lab. It will be handled by the lab. So to know the extent of water pollution in more specific and practical terms, we must precisely define the characteristics of the water. That is the parameters. And I tell you, the parameters are not one way. What I mean is that depending on what the water is going to be used for, you can know the exact parameters or the parameters you are measuring. Drinking water parameters is different from sewage parameters, or is different for ways that water that will be released into the environment or into water bodies. So these parameters are different. Sewage parameters are different. Drinking water parameters are different. So you cannot use just one particular parameter to measure for all water that you want to release. So concentration of parameters are usually measured in mg/milligram per liter or ppm. These are the parameters or how it is measured. So these are the most frequently cited parameters. We have dissolved oxygen, oxygen demand, organic content, solids, nutrients, metals, cyanide, and others. These are the parameters. And from the lab technician, you have done all this. So what I will do is that I will still send you this slide, this particular one, though it's in your lecture notes, unless you don't want it, but I can still send this particular part concerning the parameters to you, then you look at it. So This is what I wanted to know for today, that the water you use in your industries are large, they are in large volumes. And the purpose of this water usage is either to cool your equipment, to wash your equipment, or to process, or for transportation. That is the main purpose. However, because these water bodies or the water you use sometimes come in hot, they can have an effect on the work environment. They can release heat into the work environment, the environment where people are working. And if heat is released from the water into that work environment, it can affect the human heat balance. And the human heat balance is basically telling us that we have a core temperature which is 37 degrees Celsius, and it should not deviate from that. If it deviates from that, it means that you are not sweating or you are not releasing the core temperature to maintain the temperature at 37 degrees Celsius. Again, from this lecture, I'm saying that the water that you use for your operations, or whichever purpose for which we are using the water, that water can become harmful to the ecosystem, especially the aquatic ecosystem, because sometimes the water that you use for your cooling, for your processing, for your transportation, you end up releasing them into aquatic water bodies. And if you do not check it very well, it can have negative effects on the aquatic ecosystem. How does that happen? It happens when maybe the water that you have used your industry and releasing into the water body has too much nutrients, has acid mine drainage, has high metals, or you have removed the oxygen from the water. It can have an effect. And what are the effects? It can cause the pH of those water to increase, the temperature of those water to increase, the nutrient level to increase. That causes algal bloom or causes fish kill. So these are the things. So the water you are using in the industry are valid reasons. You have valid reasons to use it. However, they can have an effect on the human as well as the aquatic ecosystem. So before you release this water bodies into, for instance, aquatic ecosystem, you need to measure or to ensure that it is not toxic to the aquatic ecosystem. And we are saying that before we can even say that what you are releasing into the aquatic ecosystem is a pollutant, they have to meet certain criteria. And the criteria can be concentration, the type of pollutant, the source of the pollutant, all that, before you can say that whatever you are releasing into the water body is a pollutant. And so before you can justify that whatever you are releasing into the water body is not going to be toxic to the aquatic life, then we have to find a way of doing it. Then we use the TLC 96. You use some fish like the trout or the goldfish to determine if they are in that water for 96 hours. Will 50% of their population die? If 50% of their population dies, or that is mortality, it means that the pollutant you are releasing into the water body is toxic. It can be the amount of nutrients, it can be the pH, it can be the heavy metals, the fact that you have removed oxygen from it. But that is not the only way to determine if whatever you are releasing into the water body is toxic. We have to have specific and concise measurement. We use the water quality parameters, and there are several of then parameters, oxygen, and all that. You have to measure those parameters. And I want you to understand that these water parameters, it is not one standard. If it is drinking water, you are releasing into a water body that is for drinking or domestic, the parameters are different. The way you have to meet it is different. And sometimes you are just releasing into the environment, the parameters are also different. So these are the things you have to look at and to understand that, yes, the water you are using is for a purpose, but it can have negative effect. And you knowing all this makes you want to put measures in place to curb all these negative effects. So now, do you have any question or do you have any contributions to what I am saying